The basic idea behind the vector space model is that we vectorize the documents directly based on the vocabulary. This means we no longer have to come up with our own handcrafted features. And the result of the vector space model is that each document is represented by a vector of still a fixed size, of course, but now we know that the fixed size depends on the size of the vocabulary. And putting all vectors for all the documents together forms what is called the term document matrix, which is visualized here. So the term document matrix essentially represents the set of all documents, which are represented by the columns in this matrix, and the set of the unique terms, which are represented by the rows in this matrix. And you can quickly see that if we, for example, pick any column in this matrix, this then would represent a document vector. Now the question is, of course, what are the values in this matrix? What are these weights? And these matrix values essentially depend on the representation because there are different alternatives. And in the following, we cover the most prominent ones. First, let's have a look at our example corpus that we use in the following. On the left-hand side, you basically see the very simple corpus containing 5 sentences. And over these corpus of 5 sentences, we applied a set of very common normalization steps. So, for example, we remove all non-words, which are essentially the punctuation marks. We remove all the stop words. And if you look, for example, stop words would be and, other, there is a, on the, my as well, and in and the. And also we performed case folding, so converting everything to lowercase, and lemmatization, which for example means that we converted the lowercase and uppercase word of dogs into lowercase dog. So this gives us now our normalized text corpus, which obviously looks much more simpler, has less words. It also means that now we can directly derive our vocabulary, meaning the set of all unique words. And in this case, we only have 7 words. So now we already know that all of our document vectors will later have a fixed size of 7, because this is the size of the vocabulary. The most basic way to set the values of our term document matrix is to use binary weights. And binary weights simply means the values in our matrix are either 0 and 1, where a value of 1 tells us that a document D contains a term T. And otherwise, we set it to 0 if the document does not contain the word T. So for example, if we look in our example corpus in document 4, we see that the word appears twice, the word dog. But if we look in our document term matrix, we still see there's just a 1. Because we only care if dog is present in this document or not, and not how many times. So this means, basically this basic interpretation, that these weights indicate the presence or absence of a term or document. But other than that, there's no other differentiation between the words of a document, particularly with respect to the counts. Because again, we treat dog and watch equally, despite dog being in the document twice and watch being in the document only once. But even this basic setup is already very useful for things like filtering documents. When we're looking for documents, for example, that contain the word dog, and we don't care how often the document contains the word dog, then this basic representation is already sufficient. And this representation is also called set of words representation, because we don't care about any kind of counts and frequencies in this representation. Another basic alternative is the so-called back of words representation, where we now consider the number of occurrences of a term in a document. So now our matrix is no longer binary, so the values are no longer just 0, 1, but now our matrix elements are integers. And these integers, our weights, our matrix values, are simply the number of occurrences of a term T in document D, which we also call the term frequency. So again, if we look at our example in document 4, where we have the word dog occurring twice in our document, so this number of occurrences is now represented by this value in the term document matrix. And the general interpretation is that we most of the time like to assume that more frequent terms in a document are also more important. But we have to ask ourselves, does more frequent always mean more important? And as we will see later, the answer is generally no. And this will bring us to the TF-IDF representation.